Hello there, class. Well, our math lesson for today is called Arrays, Factors, and Multiples. So go ahead and write this in your table of contents. Factors, arrays, and multiples. Okay, turning to your next available page, which is going to be after the adding and subtracting decimals page. Okay, let's date this September the 5th. Okay, and our title is Arrays, Factors, and Multiples. Okay, so an array describes a number pattern. Factors and multiples. And their properties. So, for example, say I have this array. Okay? Okay, I have 3 boxes this way. 1, 2, 3. And 2 boxes this way. Those are my factors. Okay, those are my factors. Okay, when you multiply them, or even when you count them, you get 6. That is my product. That's my product. 3 times 2 is 6. Okay, so then the product is the answer to a multiplication problem. It is the number of tiles used to make the rectangle. Okay, so in our rectangle up here, where we had 2 squares going down and 3 squares going across, we used 6 tiles. Okay, a factor a number that fits equally into another number. We can also say that it is the sides of the rectangle in our array. Okay, so the factors up here are 2 and 3. They're the sides of the rectangle. So the factors for 6, we make a t-chart. The factors for 6 are 1 times 6 and 2 times 3. Okay, these are the factors. We can say that the factors of 8 are 1 times 8 and 2 times 4. Those are your factors for 8. How about the factors for 12? If I made a t-chart for 12. Well, let's see. I've got 1 times 12, 2 times 6, and 3 times 4. Okay, these are all numbers that fit evenly into 12. They are the factors of 12. These numbers fit evenly into 8. They are the factors of 8. Okay, one important thing to remember, the difference between factors and multiples is that factors have few numbers. Okay? Factors have few numbers. Factors, few. Okay, so now let's talk about multiples then. Multiples are the product of two factors. So we could say that 12 is a multiple of 3 and 4. 12 is a multiple of 2 and 6. Okay, here's another way of looking at multiples. You can say that it is what you say when you count by. For example, if I'm counting by threes, all my multiples of threes, 3, 6, 9, 12, 15, 18, 21, and so on, and so on, and so on. And it just keeps on going. You can count by 3 forever. Those are all the multiples of 3. Okay, how about the multiples of 4? Well, let's count by 4s. 4, 8, 12, 16, 20, 24, 28, and again, you could count by 4s forever. Okay, those are the multiples of 4. Okay, so since you could count by 4s forever, you could count by 3s forever, and multiples just go on and on and on, we could say, to help you remember, that with multiples, there are many numbers. Okay, with multiples, there are many numbers. Factors are few. There's only a limited number of factors that will go into a digit. Okay, there's only a limited number of factors that will go into a number. But with multiples, you could just keep counting forever and ever and ever. Okay? So factors few, multiples many. Alrighty, and that is it for our lesson for today. We do not have any practice problems with this today. Okay? So bring this to school tomorrow. Good night.